Welcome to Learn Dglux5 series. I'm Paul Sinenko, and today we're going to do the last part of our three-part series on zoning tool and zone consumption. In first two parts, we have learned how to create a tool, how to interact with zones, and how to store the zone information in a file. And now we're ready to create something that can consume that file and finally render our zones for the end client. We're going to look into making those zones interactive for the client and look into hooking up data for the zones to be driven by devices in the field. In our case, virtual devices in our data tree, and we'll see what it takes to do this dynamically so that you don't have to link each and every device to each and every zone and save some time on labor. In addition, I'd like to remind you that this tool will work for many of your projects, right? This is not project-specific tool. The first two parts that you've seen will allow you to create geometry and zone information that can be taken to any project. All you have to do is just have the floor plan, draw things, save the JSON file that you get as a result, and take it to any project that you want. So this tool is designed to save you a lot of time on repetitive work. And now we'll take a look at the consumption side. We'll see if we can save you some more time there by making this as reusable as possible. All right, so let's get to the controls and let's get it done together. Hey, welcome to the controls. So we're going to pick up pretty much where we left off. So basically, so here we have a floor plan and page as we left it. And there are a couple of additions that I want to make. First of all, I went ahead and created better VV simulation under data, where these VVs will actually simulate real environment, more or less. Right? They're affected by outside temperature, which is also settable, right? So the rooms will slowly heat up if the temperature is high. Right, or cool down if it's low. They'll go into heating and cooling periodically, right? And if you manually override the room temperature and set it, they'll try to heat up or cool down. So basically, they simulate a real unit to an extent, of course. For anyone interested, I will post a link to the file containing this data flow. It's a server-side data flow that I created that makes it fairly easily to generate and simulate virtually any number of VABs. So we'll make that available in comments. So meanwhile, since I now have a new set of VABs, I want to go ahead and change hard-coded path to VAB selection in my zone information form. So the form I'm talking about is this here. It's a symbol. So this form. So what I'm going to do is I'm going to go ahead and make the root node under which to look for devices. I'm going to make it a property, a page property. So to do that, I'm just going to go to modify and edit properties. And so this opens basically the same property editor as you would find in the symbol, except this is for the whole page. But it works in exactly the same way. So I'm going to add a string. I'm going to call it device root node. Right, so this will allow you to configure the tool to work with a set of devices somewhere in your tree. And I'm going to pre-populate this with my root device node, which is building A. Right, holding control, I'm going to drop it here. And I'm going to take this property. Right, I'm going to go to edit my zones data. And now I could actually bind it right inside here using add page path, which would always be relevant. But I'm going to take the high road here, and I'm actually going to create a symbol property so I can pass this node as a parameter. This will keep my form a bit more universal, maybe for further reuse elsewhere. So device root node on, and again, because I cannot open this in context, actually no, I can't. So I'm going to keep it at that. Close this. Remember, we opened this from a symbols panel completely out of context. So now I'm going to go to where this
form is actually used as a callout, which is our raw XVG repeater. This is that callout. Right now I see this property that I've just created. I'm going to go ahead and bind it. Right, and now to open this callout in context, I'm going to select the SVG repeater in design mode, of course. So it shows me my callout. I'll just double click. And now I'm editing this form in context. Of course, by in context, I mean that all the data that I've been passing to the symbol is passed into my editing environment here. So, and this is my device root node. So I'm going to grab this. I'm going to go to where, basically where I'm getting these devices from. I'll just trace it right back from my options list. Right, so here it is. I'm just doing list node on a hard-coded node. So I'm going to bind this. Right, and I could add some sort of filter saying like find, only include things that have VV in the name, because if you noticed, I have a node here that's called outside temp, and it's also being brought in. I'm not going to add any filters because I want this tool to be usable in a wide range of environments where things may not be named the way I expect. So I'm going to leave it up to the user to select proper item from the dropdown. So I'm not going to add any more restrictions here. Again, keep in mind, this is a tool for an engineer. So we're assuming some level of competence here. So we're not going to lock everything out. Okay, so that's that should do what we want here. So I'm going to go ahead and save the symbol. Right. So now if I change, so if I go to my page properties, right, and change this root node, if I had a building B here, for example, right, then it would, in the form, it would show me VVs from building B. This way you can open this tool in various environments. As far as when and how to utilize this property, so let me go ahead and save this. Right, so if I had a new page and I had a page include, right, like this, in which I decide to load my my tool. So I take my zone tool from here and use it as the source. Right now, when I update the property set, you notice that this page property that I created on my zone tool page is now available here as a property of my page include, and I can pass data right into here. Right, so I can literally go ahead and give it the node from in here. Right, so I can say that this is now my my root node, right? Or again, use the new one that I've created, which is building A. Okay, so that's why I created this page property. Okay, going back to our tool. So let's go ahead and create some zones, save this configuration, and then we're ready to start working on our consumption side of this tool. All right, I think we have enough rooms to play with. Next, let's go ahead and name them and select VV responsible for each of them. Okay, so now we're ready to try and save our config. So let's call this Building A, floor 1. Right, save. Let's go ahead and review what we got. So under configs, this is what got saved. Right, so this doesn't give us much. So let's try to go ahead and open new page and look at it through parser. Right, so I'm going to use string loader to load this JSON. And we don't need any headers, just path is fine because this is local, so that's the JSON. Let's use the JSON parser. Okay, so looks something like this, right? So we're looking at geometry, of course, which gives us actual zones and information about them. It looks like I have some ghost zones that are just never deleted, that are unfinished. Fine, we'll deal with it later. And of course, if we look at the outside of it, outside of the geometry, we have image path here and dimensions. This should be everything we need to actually go ahead and start building the consumption side, which, as you can imagine, will reuse a lot of what we built for the tool itself, because it's really going to be a subset of what we've already built, with the addition of different interactivity and data involvement, which we didn't have with the creation tool. So let's go to that section and start working on that. Okay, so I just created a clean slate. I've deleted a lot of garbage from this project. Renamed the zone tool part 2 to just zone tool. Obviously, it doesn't save the current state, so you can see when I reopened it, I have nothing here, but it's fine because we already have our configuration saved right here, if you recall. So now I'm only here to steal things from this page. Most of all, I need the SVG repeater. This is what draws zones. So I'm just going to copy the repeater from here, go to our new page, and this is going to be our new viewer tool. Let's call it that. I'm going to insert, of course, a group to host this. We'll call it canvas, just like we did in the tool itself. I'm going to paste what I copied. There we go. So let's make canvas fit ratio so it can work the same way it did in the drawing tool. Okay, now obviously we're missing any data that we need to feed any of this. If we go back to zoning tool, if we look at what feeds this repeater, right, it's actually on the data flow of the canvas. So, right, so it's being fed by this processing table. Right? We shouldn't need any of this, I think. Actually, we do because we still want interaction. So let's go ahead and copy everything. As a matter of fact, okay, let me step back for a second. I'm going to copy the whole canvas. Right? Just go to my new view. So I'm going to delete this and paste the whole canvas. There we go. What I don't need is I don't need the current zone repeater because we're not allowing drawing here. So I don't need anything that reflects unfinished zone. So I'm going to delete that. I do need capture group because that's what's going to tell us which zone is being hovered or clicked, because we still need that interaction. So there we go. So now we're ready to try and feed our repeater and our image. So first we need to read in the file, the configuration file. So I'm going to go ahead and try to build this right on the stage. I'm going to use string loader to load in the JSON. Right, for now, hard coded. but I will make this a parameter of the page because we want to be able to load any of these config files. So there it is, right? And this is what we have. So now we need to parse it in a few ways. We definitely need geometry. So let's go ahead and try to parse geometry out of this. I think that's going to happen by default without even specifying any parsing rules, right? So we just get this. So I think this is ready to pretty much use right away. So let's try to go to canvas, right, where we have zones. So what do we have here? We have UID chords, and here we have UID chords name path. Yes. So let's go ahead and try to use just bind it right into our zones table. Look, that just works. There's nothing else we need to do there. Love when that happens. Next, we need to know the dimensions, and we need to know the image source to load our proper floor plan. So we need another parser. Let me try to parse the top level of this. So instead of geometry, we're gonna, yeah. So this is what we need. So we went without a selector. So rather than picking objects inside, we just parsed the top level, which gave us those three things that we need. So the canvas fit ratio, of course, is important. This is coming from the image, right? Image is right here. So let's go ahead and bind this to the URL. Right? And for the image size, we are going to use these. Okay, so we're halfway there. Right? So now we have a page that's able to read configuration and just generate the same thing as we saw in the drawing tool. So let's go ahead and make the configuration path a parameter. Again, I'm going to make it a page parameter. So I'm going to go to edit properties. One trick about editing properties, well, not a trick, you just have to know this. You shouldn't have a symbol selected anywhere in your outline when you go there, because if you have a symbol selected, then when you go to edit properties, it'll think you're trying to edit symbol properties. So you'll open that symbol and open its properties. So anywhere is fine, just not a symbol. You can select stage to be safe if you want to. So again, page properties, green. Let's call this config path. We'll pre-populate this with this config file and use it as a source for our stream loader. Done. Okay, so we're almost there. Now our interaction does not work anymore. Right? We need to take a look at that. And also, we don't need the form that, well, we don't have that form anyway. So to get our interaction to work, it should be simple. We should just have to copy the SVG tooltip. If you recall, we used that to report the hovered zone. So I'm going to copy this from this page and just go and paste this here. So that, yeah, there you go. So that immediately makes our interaction work, and we could certainly use it, even the selection. However, the right click doesn't do anything because we did not move this call out symbol to the new page, and we didn't do that because we don't need it. We'll build another one, or maybe we'll just take that one and modify it further. We'll see. So again, we're a little bit further now, right? We have a page that's able to take a JSON file and display it as it was saved, loading the image, creating the zones, and maintaining zone interaction. So next step, we need ability to specify which metric should drive zone attribute. We'll deal with color for now. So let's go ahead and work on that. All right, so we'll do a little housekeeping. I've saved the page as view zones, so it's no longer a new page. so we can keep saving our progress. And I realized that we have more than one configuration, so we can go ahead and try to replace that just for fun. So instead of this one, we can load another one. This is the one we've created, I think, in part 1 or part 2, maybe one of those. So you can see that it loaded completely different config. So everything works just like we intended to. Okay, so now we're truly ready to start working on the data portion of this, to start making these zones do some useful work for us. Okay, so we're here, we're able to load our configuration, we're rendering zones, we're ready to link the data to the zone. For that, we need to know a few more things about the configuration that we don't yet have. So we store path to the device that controls a specific zone. However, we're not specifying the metric which is supposed to be controlling a zone color within each of those devices. Now, we're going to assume that it's going to be the same metric for all these zones. So if we're displaying room temperature as an example, then we're assuming that for every VV, the room temp point name is the same. Now, if it's not, then you get into different territory and you would have to use some other means to look it up. We have to take the common scenario here for the purpose of the video, and we're just assuming that all the VVs that we have the point name RM_temp, room temp, so which we do. So we'll take a look at list of our simulated VVs. Each one of them has this point, and that's what we're going to use to map the color to the zone. So again, we have the path to the VV itself, which is part of the zone information. We need to add the metric information to this page. Now, we're going to do this using page properties here. So we're going to actually create a whole section. We'll call it metric config. And first thing in there would be our metric name. All right, now let's pre-populate this with that particular value. Okay, so notice I'm not building any user dialogues or controls for the user to pick what he wants to use to map this, because we're building this as a widget, right? So basically this page will take parameters and you'll be able to embed this page as a widget into more encompassing interface, where you may add your controls to pick the metric, and you would just have to feed that metric in here into your page widget, which is going to be nested in your greater UI infrastructure. So we have the metric now. We need to know a few more things. We need to know range and color. So let's go ahead and add a horizontal box, and we'll add 2 numbers, right, which are going to be our min and max. And we'll set min to be, let's say, 55, and max to be 95. And we need to know our gradient, which corresponds to this range. So we'll add a fill property. We'll call this, let's not call it temperature, because this may not be a temperature that we're mapping. We'll keep this universal. So let's call it range gradient. And of course, we can't have any dots in between. It has to be an underscore. And let's set it to be basically a gradient going from blue into green, keeping green for a while, and then going into yellow and red towards the far range. We can always play with this range and also with min max in order to get our color to follow the path that we want. Okay, so this gives us everything we need to now
knowing the value of the room temperature to calculate the color. So let's go ahead and do that. So here in the data flow of our canvas, right? So right now we have this column mapping table, which adds a color of the zone using two hard-coded colors. It simply uses one if our UUID matches the clicked item and another if it doesn't. Of course, we need to parameterize them. Now the clicked color will remain hard-coded for now, but let's use the color that's not in our gradient range. Let's use maybe just gray. So clicked will be gray. It will look like this, right? However, for our normal color, right, that's a different story. So we need to calculate that. For that, we need to build a symbol that gets us the value of the metric and maybe the hex for the color as well. So let's do this. Let's just drag out this get value block and convert it to a symbol right away. We'll call this get val and color. And we'll get in there. So it's going to take a few parameters. It's going to take path to the device, which our table has, and it's going to take metric name, which our page property has. Okay, so let's go ahead and save this for now. Let's stick it in a repeater right away. So we're going to get a repeater out here. All right, we'll bring the zone into this repeater. We'll repeat the symbol we've just created, which is now under our symbols, get value color here. Click outside, click back in. Now we have these properties. Let's link them. So this is going to be the path, right? And page property is going to get us the metric name, right? We also need UUID here so we can later match what we got. So let's go back to our symbol, symbol properties, UUID. And that's going to be, of course, just a direct binding from our repeater source table. Okay, so now let's delete the single instance and just work with this repeater from now on. So now if we edit one of the instances, right, we now have everything we need to populate the path and get appropriate value. So let's use concat block. All right, add a slash to it and the metric name, and the whole thing will go into the path. So now each instance of this symbol will be able to get its own value. So now we need to convert the value to the color. Of course, we need to know the color here. So let's add a fill property. Call this a gradient. And we need to know min-max. All right, let's save the symbol. Right now they're here, so let's go ahead and link them. They also come from page properties that we've created. All right. Going back into it. So this time we have more info. Right now we have everything we need. So we're going to use a special block, gradient mapping, which will do most of the work for us. And so it takes a gradient as an input. Now you cannot simply bind a fill property to this. because fill property is not the same as a gradient. Fill property is a parent of a gradient, right? It contains various fill types. So we just need a gradient. For that, we open this property, right? Open the editor, and we get this blue dot, this outer one, right? The inner one will grab this color for a single stop that you have selected. This outer dot will grab the gradient itself. So that's going to go right into here. Right now, we link the min-max. That's self-explanatory. And finally, our value. So that gets us the output color. However, there's a slight problem, right? We get this in this unusual format, which is RGBA. It's not really usable inside SVG. We need a hex version. So this block is a bit of a relic. That's why it still has the RGBA output instead of a hex. I'm going to use a script block. Right, and I'm going to create a very simple script. So first of all, I'm going to create a color property. So property named color, it's a string property, right, to bring this into the script. And the script itself would be something pretty simple. I didn't even fully write it myself. What I did is just I Googled color RGBA to hex conversion. I found the JavaScript for that, and I just modified the script slightly to adjust it for DGScript, right? There are a few differences. For example, the way you convert something to a string. Now in DGScript, the syntax is basically the word string, and then in parentheses, the string itself. And then if you want it to be in hex format, you do comma hex. Right, where in JavaScript, it's usually the string itself, dot to string, and then in parentheses 16 for hex. So just slight syntax differences. Here you can look in this and compare what you find in Google when you search for JavaScript RGB to hex color conversion, and just create yourself a little data flow symbol that does this from now on. Okay, so this outputs basically a hex color format, which is what we need. So now we just need to create the two output properties. We're here. So we're going to output a value. We're going to do it in the form of a string, just so this block. Actually, no, we don't need to do it a string. This block will only work for numeric anyway. So let's do number for value out. And let's use a string for color. And both of these, of course, will be read-only because the symbol will only output them. It will not take an input. So value out will be just our get value block. And hex will be the color. Okay, so now if we look at our output of this repeater, right, we have a table, right, that gets us the color value. But we're not handling the lack of value, right? You can see that we have 4 zones that are unassigned to any VAVs, which means there's no value. So we're not showing any color. Let's fix that. Let's have a deep fallback color if there's no value. So let's get back in here and add a simple if block. Right, so we're going to say if this output is nothing, right, null, right, then we're going to basically use hard-coded color. Let's use the kind of just light gray, right? Otherwise, use the actual hex, and that's going to go into our color output, right? So this should have, so now you can see it populated the missing line items with just a light gray color. Okay, so now we can go ahead and join it with with the zones table. So let's do join. Right, we're gonna obviously be joining on a UUID column. Right, so which gets us this. Some of the columns are, they occur in both, so we just get one of each. But what we care about, of course, is these two, the color, well, especially the color. Right, and this would keep going into our column mapping block. The only thing we have to now change is, we're adding this color column, which we already have, right? We have a color that's coming from our repeater, so we can't add a column with the same name. So let's change this name to zone color, right? And we'll modify the expression for this, where if before both colors were hard-coded, the clicked color and unclicked, we're going to keep the clicked color hard-coded, but unclicked one will simply reference the color column that we already have at this point. So when we look at the result, right, so we have zone color, which is basically a copy of the color column, except for any line item that's clicked. So now we should be able to just go back to our zones renderer, so basically a repeater, and modify our SVG code slightly. So it's here, right, in this replace block. So I'm going to open this and modify it slightly, where before the zone color was based on color column, let's now base it on zone color. Okay, so notice right away we have, so click gives you gray, that's fine, but we already have some zones that are, different colors there. So let's play with our gradient a bit to kind of underscore the difference in temperatures. I think most of our rooms are somewhere in the 70 something range, so let's just shorten this. Right, and we'll say everything beyond 80 degrees, or whatever, will be red. So you can see immediately how things are affected. Okay, so let's go ahead and change, maybe force change some of the temperatures here. So let's do VV2. It's currently, the room temperature is 71. So let's change the cooling set point. Let's raise it all the way to 85. Right, and just to speed up the room heating, let's set the heating set point to 80. So it'll heat up the room real quick, so we won't have to wait. So there, it's heating up. All right, so you can see room temperature is going up. So if we look at our table, so this was VV1-2, which is 1-2, it's right here. Right, so you can see that it got heated up, so it's 80 degrees now. And 1-2 is, who is it? It's Bill's office. Oh, well, actually, we don't have a tooltips yet, so we don't know what Bill's office is. So let's quickly check, because I don't see visually, I only see one zone being different, so maybe something's not being calculated correctly. So on the canvas, we're going to go to this Bill's office. So we're going to edit number index 1, 0 being the first line item, and 1 being the second. Okay, and that's the color we're outputting based on this gradient. Are we really still in the green at this point? So let's see. Let's see if we shift the gradient a bit into the green territory. Like this. Okay, yeah, so just our gradient was set up in such a way that it was basically most of the temperatures fell in the green territory. So we're fine. We're fine with our logic. Yeah, you can now tell that things start looking different. So as they heat up, they become yellow. Just our gradient was not very reflective of that. So let's make it even more sensitive. So shift green into here and yellow all the way in here. So you can see how things are now being affected. Now, most of these VVs have the same set point. That's why they all greenish like that. But we can easily heat up another room here so you can see the effect. Let's do 1.6. So let's cool it down. So let's set a cooling set point to 59. All right, and we need to bring the heating down all the way to 55 so it doesn't try to heat it up. So we should, okay, now you should see it start cooling down. So let's keep looking. One of them should cool down pretty blue. I think it's this one here. So you see the temperature is dropping. Yep, there you go. It's getting blue in Bill's office. Or no, this is not Bill's office. This is something else. But anyway, so you can see how our system is now working quite well. We can replace the metric on the fly. So if we go to modify and we decide that we now want to plot our set points, let's say cooling set point, all I have to do is change this metric name. STPT. Right, and all of a sudden now I'm mapping the cooling set point, right, instead of room temperature. Or let's say supply. Let's plot a damper. That should be good. So let's do SA damper or DMPR. Oops, just no plus. We need to underscore, and the range will change from 0 to 100. All right, and the gradient, of course, will change from, it's just blue to red. So now when we start changing set points, you see when this dampers open and close. So right now you can see this is 58%, for example. So if we force it right now to start heating things significantly, so let's raise the cooling set point to 85 and bring the heat up to 80. Right, see how this became purple right away as the damper kind of popped open to 100. Right, and then when it gets to the temperature, as the damper starts closing, you'll see this shift back towards the smaller value. Right, so you can see how quickly we can operate this. And when I said it's widgetized, right, so this is what you can do. So let's go ahead and close it. And let's say you're building your page, and somewhere, actually we have a page. Let's pick one of the prior pages, the index here. So let's say we wanted to insert a floor plan into this content, right? So I would go and insert page include. So components, page include, just gonna blow it up. The source for that would be view zones, right? The path, now the reason we already see this is because I pre-filled the properties of the page, if you recall. So so we're gonna still explicitly tell it which config to use, just so you know, if we drop another one here, right, right, it will render the other config, right? But this one is not pretty, so let's go back to our pretty config, this, and need to populate our metrics. Where's I really hope I saved the page before I closed it. DGLogik channel, view zones. Ooh, okay. I did not save it. Luckily, there's such thing as recovery. So we're going to go to File, Recover. I'm going to go to our view zones here. Let's check it. Okay, this one already has everything we need. So that's good. So we'll just do File, Save As, View Zones. Okay. All right, so let me just change the metrics here to the room temperature, which was what? RM temp. Okay, and I'll save this. So, okay, let's go back to our index here. Okay, so now, right, these metrics, these properties are shown here. So again, room temperature is what we're plotting. Let's do between 55 and 90. All right, our gradient will be, let's go back to our blue, green. I'll do green, yellow, red. All right, so there you go. So if I wanted to pick a metric selector, I would add it here to the content and feed its result to my metric name, maybe along with a gradient and so on. So I just built myself a widget to visualize a floor plan and zone configuration that was built using the zone tool. Now, there's a lot more kind of bells and whistles that you can add to this. You can create pop-ups, so clickable pop-ups, not tooltips. So when you mouse over, you see the information of what you're rolling over. And that, of course, is achieved by something we already have. So let's go back to view zones. If you recall, we already have the SVG tooltip, right? That's what helps us identify the hover zone. It's just everything inside right now, right? So if we look inside right now, there are no visible components in there, right? It's hidden. However, it wouldn't be difficult to unhide and add components that are not hidden, so that when you mouse over, you do see something. So that's what we're going to do right now. So we're going to edit properties. We're going to add one more element, call it zone name, and we're going to unhide this, and zone name will be simply bound to this text. Hit OK, and we're going to go to our SVG repeater. There, go here, get to that data tip renderer, and I'm going to bind the name to the zone name, which should basically get us, it's white on white, so let's tweak color slightly. So it's going to be fill and stroke, so it's going to be maybe a white fill with a drop shadow. All right, okay. Right, with darker text. All right, and what are we not liking here? All right, so sometimes we need to save and reload. Yeah, there you go. So see, simply saved and start working. So we're dealing with data type render on SVG repeater can be a little bit tricky. So if you see something that you feel that you've done right, but you just don't see its result taking place, save and refresh the page. Sometimes it takes reloading of the symbol to for it to start working properly. There you go. All right. Well, that's as far as this final part of the Zone Builder series goes. This should give you more than enough ammunition to create your own tools and also consumption widgets for the data that those tools produce. You will find in the comments under the video, you will find a copy, basically a zip of the data flow that will allow you to create simulated devices if you want something to play with. And of course, the page itself will be available for download, again, linked under the video. So that's it. Now you have another tool at your disposal, which hopefully will make your zones and floor plan pages quick work from now on. And you also hopefully know a lot more about SVG Repeater and how to use it to your advantage in the future to create dynamic geometric systems. Until next time, I'm Paul Sinenko. Go build something.